He says, I just finished reading How to Lie with Statistics. It was a pretty short book. I just wanted to read this out so maybe you guys would maybe remember a couple of them and maybe notice them if you see them. But this is a list of ways to lie with statistics. And our opponents have probably used all of these many times over the last few years, and you could identify times that they've used each one. So here they are. So use a non-random sample, then extrapolate from that sample to the entire population. So a favorable sample and then pretend it's representative. Refer to the median or mode as an average. They are by some regimes, they're types of average. But mean average is the one that people know of as average, where you take all the values and you add them together and then divide by the number, so you get the exact middle value, the balance of the values. Mode, I think, is the most common specific value. So if you have 3 times 5 results and then 2 times 6 results, 5 is the mode average, I think. And then median is you take the lowest and the highest and you just take the middle of those two values. So median and mode have their place, but they're not the same as mean average. A mean is the one people think of as average. So I can see that being misleading in some cases. Use the average when talking about a highly skewed data set. You've got to control for anomalies and you've got to recognize what is skewing it. Do a survey over and over with a small sample size until you get the result you want. That one I expect is quite common. Use misleading graphs with non-uniform or truncated axes when describing data. There is a time and a place for non-uniform or truncated axes, like if you have a logarithmic scale, or if you have just a part of the scale, just the part that's relevant, but you leave out everything from 10 million back down to 0. You leave that out because it's not relevant because all the data is at 10 million and upwards. It makes sense to do that sometimes, but it should be very clearly labeled that you're doing it. And if so, use the little sort of like squiggle at the beginning of the axis just to show it. And I would like there to be a symbol for a exponential curve or exponential scale as well, but there isn't really a good way of doing that. Of course, labeling it helps, but people can still be easily misled by the curve looking the wrong shape because of that.
They did a lot of this in COVID times with a lot of their statistics. Like that was all they were doing.
Yep. Use percentages or decimal points because people will always assume that the numbers were precisely measured even when they're not. You can do a lot with percentages because there's only 100 numbers to work with. If the difference of a percent makes a difference, you can easily jig it over the line. Suggest that correlation implies causation. It's an obvious one, but that is often done. It's actually a very common, I guess, logical fallacy. It's more common than you might think. Even when it's very abstracted. Use ambiguous or misleading statements, kind of an obvious one. Use percentages and switch back and forwards between percentages and percentage points. And percentiles. These 3 things are different. So if you say, for example, earlier, when we were talking about Trump and Nikki Haley, Trump at 54%, Nikki Haley at 43%. 54 and 43, the difference between those is 11. But it's not 11%. 11% or 54 is way less than 11 percentage points. That's why it's important to say a difference. 11% of 100% is the difference between them. But if you say that she's 11% behind, it implies that she's behind by 11% of 54, which is not the case. So you always say percentage points or points. That's why they say that, by the way, chat, in case you didn't know. And percentile is about getting a proportion of the total instances that are available. So if you are in the, I don't have an instinctive understanding. I don't have a great instinctive understanding of this, but the 1 percentile is, I think, or the top 1 percentile is the results that are within the top 1% of the range of all results. And you get the things that are in that range. That's very different than percentage or percentage points. I've not seen that being used to confound the difference, but I suspect it has been. And then suggest that a historic data trend will continue indefinitely into the future, which is another one. It's just a bad extrapolation. Something that they do with birth rates as well, by the way, I mentioned earlier.
Mm-hmm.
So yeah, it's a bunch of, I'm sure that there are plenty more besides these. I mean, the one I would put on here which is very obvious. And you could argue it's included in one or two of these, but just checking with definitions. That's the easiest way to lie with statistics, is just fucking around with definitions. Using a non-standard definition or wording it in a way to change the meaning of one of the premises. Clearly, if there's something clearly that you want to imply that you've studied, but the wording just slightly does not mean that, you can lie very easily. There's a selection of strategies to be aware of, chat.